last video, you looked at how to find GCF of variables and of numbers. So now let's put it together. So if you want to find the GCF of a polynomial, the first thing you need to do is find the GCF of all the coefficients first. So treat each piece separately. Then look at the variable that is common to all of the terms and take the one with the smallest exponent. You will write your GCF as the number from step 1 and the variable from step 2 as a product. So, for example, find the GCF of each of these polynomials below. So when we look at 3x and 12, first we're going to look at the numbers. So we look at 3 and 12. 3 is a prime number, so there's only 1 and 3. Since 3 goes into 12, we know that 3 is part of the GCF. Then we look at the x's. There's not an x with the 12, so we know that our GCF is simply 3. When we look at b, we see that both terms are 7. So when we look, we just have a 7 and a 7, so we know 7 is the part of the GCF. Since there's no y, then we know that 7 is our GCF. You try C. So when you did C, you should have gone and first focused on the 20 and the 30. So making the factors of 20, you know you have 1 and 20, 2 and 10, and 4 and 5. Since 20 doesn't go into 30, we know 20 can't be the GCF, but 10 does, so we know that 10 is part of the GCF. When we look at the variables, we see that we have an x and we have a y. Those are not alike, so 10 is our GCF. Looking at D, first focusing on the numbers, we look at 8 and we look at 36. So the factors of 8 are 1 and 8 and 2 and 4. 8 goes into 36, so we know that 8 is part of our GCF. Then when we look at our variables, we have an m and we have an mn. Since both terms have an m, then we know that m is the GCF. So our GCF is 8m. Looking at E, starting with the numbers, 4 and 24. The factors of 4 are 1 and 4, 2 and 2, and that is it. 4 goes into 24, so 4 is part of the GCF. When we look at the variables, we have a y squared and a y. We take the one with the smaller exponent, so it's just y. Looking at F, we're looking first at 15 and 30. The factors of 15 are 1 and 15 and 3 and 5. 15 goes into 30, so 15 is part of the GCF. Then looking at the variables, we have a squared times b and ab. We take the a, since there's an a in both, there's technically 2 in this one and 1 in this one, so we take the 1a out. Each of them have a b, so we can take out the b as well. Now take a couple of minutes, and do G, H, and I. Here are your answers for G, H, and I. Remember that you're looking for the largest number that divides into all of the numbers, and then the variable that's common in all of the numbers and has the smallest variable. When we look at J, K, and L, now instead of having binomials, we have trinomials. We have 3 terms instead of 2. So it works the exact same. You're still going to look at the smallest number of all of the numbers. So we have 3, 12, and 48. So we're going to look at the factors of 3, which are just 1 and 3. So since 3 goes into 12 and 48, we know that 3 is part of the GCF. Then we look at the variables. So we have an x squared, we have an x cubed, and an x to the 5th. We take the one with the smallest variable, or the smallest exponent, which is x squared, so we pull out an x squared. Because we know that there are 2 x's within 3 x's and 2 x's within 5 x's. So our GCF is just 3x squared. Now you take a couple minutes and do K and L. Here are the answers for K and L. We can see that 2 went into everything for K, as well as there was 1 x in common. And then in L, there was a 5 in common for all of those terms, and then an h. Note that with 25 and 15, or with 15 and 30, 3 also goes into them, but 3 doesn't go into 25, which is why 3 could not be the GCF. Stay tuned for our next video where we actually factor out our GCF from our expression. Have a great day.